The National Electrical Code, or NEC, serves as the minimum safety standard for electrical installations. It's crucial to understand that adhering to the NEC ensures a baseline level of safety, but it doesn't necessarily encompass best practices or account for future needs. Many experienced electrical professionals advocate exceeding the minimum requirements outlined in the code, as it often leads to increased customer satisfaction, enhanced safety, and long-term reliability. When considering electrical installations, especially in residential settings, it's important to anticipate future needs and potential upgrades. For instance, in a large modern home, relying solely on the minimum number of circuits specified by the NEC for a kitchen may prove inadequate. The proliferation of kitchen appliances, from countertop ovens and blenders to coffee makers and instant hot water dispensers, demands careful consideration of circuit capacity. Installing additional circuits and outlets beyond the code minimum can prevent overloading and ensure that the homeowner can utilize their appliances without tripping breakers. Regarding outdoor outlets, the NEC specifies requirements for weather protection and grounding. However, anticipating the homeowner's potential use of decorative lighting and other outdoor electrical equipment is essential. Strategically placing switched outlets at grade level and under soffits can provide convenient power sources for seasonal lighting displays and other outdoor applications. This proactive approach demonstrates a commitment to meeting the homeowner's needs and enhancing their overall experience. Furthermore, ground fault circuit interrupters, or GFCIs, are crucial safety devices that protect against electrical shock. While the NEC mandates GFCI protection in specific locations, such as bathrooms and kitchens, it may be prudent to extend GFCI protection to other areas where moisture is present or where electrical equipment is used near water. This added layer of protection can significantly reduce the risk of electrical accidents. Service calculations are a critical aspect of electrical system design. These calculations determine the appropriate size of the electrical service to meet the anticipated load demands of the building. While the NEC provides guidelines for calculating service loads, it's often advisable to factor in potential future expansions or additions. Adding capacity to the service can prevent the need for costly upgrades later on. The NEC is updated regularly to reflect advancements in technology and evolving safety standards. Electrical professionals must stay abreast of these changes and ensure that their installations comply with the latest code requirements. However, code compliance alone is not sufficient to guarantee a safe and reliable electrical system. Electrical professionals should exercise sound judgment and apply their knowledge and experience to create installations that exceed minimum requirements and provide long-term value. When performing electrical work, it's essential to use high-quality materials and follow industry best practices. Proper wiring techniques, secure connections, and thorough testing are crucial for ensuring the safety and reliability of the electrical system. Electrical professionals should also prioritize clear communication with their clients. Explaining the benefits of exceeding minimum code requirements and discussing potential future needs can help clients make informed decisions about their electrical installations. Providing excellent customer service and going the extra mile to meet clients' needs can foster trust and build lasting relationships. The NEC provides minimum requirements for conductor ampacity, which is the current carrying capacity of a wire. Table 310.16 in the NEC specifies the allowable ampacities of insulated conductors rated up to 2000 volts based on their insulation type and temperature rating. It's important to select conductors with adequate ampacity to handle the anticipated load. Overloading conductors can lead to overheating and potentially cause a fire. The NEC also specifies requirements for overcurrent protection, such as circuit breakers and fuses. These devices are designed to protect the electrical system from overloads and short circuits. The size of the overcurrent protection device must be properly matched to the ampacity of the conductors it protects. Installing overcurrent protection devices that are too large can compromise safety and increase the risk of fire. Grounding is a critical safety feature of electrical systems. The NEC specifies requirements for grounding electrical equipment and systems to provide a low impedance path for fault current to return to the source. Proper grounding helps to prevent electrical shock and minimize the risk of fire. Bonding is the process of connecting metallic parts of the electrical system together to create an electrically conductive path. Bonding helps to ensure that all metallic parts are at the same potential, reducing the risk of electrical shock. The NEC specifies requirements for bonding various components of the electrical system, such as metal conduits, enclosures, and equipment grounding conductors. Arc fault circuit interrupters, or SIs, are devices that detect arc faults, which are dangerous electrical conditions that can lead to fires. The NEC requires SI protection in certain locations, such as bedrooms, to help prevent electrical fires. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert excess voltage away from sensitive electronic equipment, preventing damage. The NEC recommends the use of SPD in residential and commercial buildings to protect against voltage surges. Electrical panels, also known as load centers or breaker boxes, distribute electrical power throughout the building. The NEC specifies requirements for the installation and wiring of electrical panels. It's important to ensure that the electrical panel is properly sized to accommodate the anticipated load and that all circuits are clearly labeled. Conduits are raceways used to protect electrical wiring. The NEC specifies requirements for the types of conduits that can be used in different locations and applications. Conduits provide physical protection for wiring and help to prevent damage from moisture, chemicals, and other environmental factors. Electrical boxes are used to enclose wiring connections and protect them from damage. The NEC specifies requirements for the types of electrical boxes that can be used in different locations and applications. Electrical boxes must be properly sized to accommodate the number of conductors and devices they contain. Wiring methods refer to the techniques used to install electrical wiring. The NEC specifies requirements for various wiring methods such as non-metallic sheathed cable, armored cable, and conduit wiring. The choice of wiring method depends on the application and the environmental conditions. Electrical equipment must be properly labeled to identify its voltage, amperage, and other important information. The NEC specifies requirements for the labeling of electrical equipment to ensure that it is easily identifiable and that users are aware of its electrical characteristics. Electrical inspections are conducted by qualified inspectors to verify that electrical installations comply with the NEC and other applicable codes and standards. Electrical inspections help to ensure the safety and reliability of electrical systems. Electrical permits are required for many types of electrical work. Obtaining an electrical permit ensures that the work will be inspected by a qualified inspector and that it complies with applicable codes and standards. Continuing education is essential for electrical professionals to stay up to date on the latest code changes, technology advancements, and best practices. Continuing education courses can help electrical professionals improve their skills and knowledge and maintain their professional licenses. Electrical safety is paramount when working with electricity. Electrical professionals must follow safety precautions to prevent electrical shock, arc flash, and other electrical hazards. Using personal protective equipment, such as gloves, safety glasses, and arc-rated clothing, is essential for protecting against electrical injuries. Lockout-tagout procedures are used to de-energize electrical equipment before performing maintenance or repairs. Lockout-tagout procedures help to prevent accidental energization of equipment and protect workers from electrical hazards. Grounding and bonding are essential for electrical safety. Proper grounding and bonding help to prevent electrical shock and minimize the risk of fire. Electrical professionals must understand the principles of grounding and bonding and follow the NEC requirements for these systems. Electrical fires can be caused by overloaded circuits, faulty wiring, or other electrical hazards. It's important to take precautions to prevent electrical fires and to have a fire extinguisher readily available in case of a fire. Electrical shock can be fatal. Electrical professionals must take precautions to avoid contact with live electrical conductors. Using insulated tools and wearing appropriate personal protective equipment can help to prevent electrical shock. Arc flash is a dangerous electrical phenomenon that can cause severe burns and other injuries. Arc flash can occur when there is a short circuit or other electrical fault. Electrical professionals must take precautions to protect themselves from arc flash hazards. The NEC provides guidance on arc flash safety and requires the use of arc-rated clothing and other personal protective equipment in certain situations. Electrical hazards can be present in any workplace. It's important to be aware of these hazards and to take precautions to prevent electrical accidents. Following safety procedures and using common sense can help to minimize the risk of electrical injuries. The National Electrical Manufacturers Association, or NEMA, is an organization that develops standards for electrical equipment. NEMA standards help to ensure the safety and performance of electrical products. The Underwriters Laboratories, or ALL, is an independent organization that tests and certifies electrical product. UL certification indicates that a product has been tested and meets safety standards. The Institute of Electrical and Electronics Engineers, or IEE, is a professional organization for electrical and electronics engineers. IEE develops standards and provides educational resources for electrical professionals. The International Association of Electrical Inspectors, or IE, is a professional organization for electrical inspectors. IE provides training and certification for electrical inspectors. The National Fire Protection Association, or NFPA, is an organization that develops codes and standards for fire safety. NFPA publishes the NEC, which is the most widely adopted electrical code in the United States. The NEC is a comprehensive document that covers all aspects of electrical installations. It is updated every 3 years to reflect advancements in technology and evolving safety standards. Electrical professionals must stay abreast of these changes and ensure that their installations comply with the latest code requirements. The NEC is organized into chapters, articles, and sections. Each section of the code addresses a specific aspect of electrical installations. The NEC uses a numbering system to identify each section. For example, Section 210.52 of the NEC addresses receptacle outlets and kitchen countertops. The NEC contains tables and figures that provide additional information and guidance. These tables and figures can be helpful for understanding the code requirements and for performing calculations. The NEC is a complex document, but it is essential for ensuring the safety of electrical installations. Electrical professionals must be familiar with the NEC and follow its requirements to prevent electrical hazards. The NEC is a living document that is constantly evolving to reflect advancements in technology and evolving safety standards. Electrical professionals must stay informed about these changes and adapt their practices accordingly. The NEC is not a substitute for good judgment and common sense. Electrical professionals must use their knowledge and experience to make decisions that are in the best interest of safety. The NEC is a minimum standard, and electrical professionals should strive to exceed its requirements whenever possible. By going above and beyond the minimum requirements, electrical professionals can provide their clients with safer, more reliable, and more efficient electrical systems. Furthermore, under-promising and over-delivering leads to great customer relationships and referrals.